Hello, my name is John Sharp. I'm a new postdoc at the UW Cooperative Institute for Climate, Ocean, and Ecosystem Studies. I have a background in marine chemistry with specific expertise in the chemistry of dissolved carbon in seawater, biogeochemical cycling, and seawater ionic interactions. A motivating factor for my research has been the carbon dioxide that's been released into the atmosphere as a result of human activities like the burning of fossil fuels and changes to the way we utilize land. This carbon dioxide and other greenhouse gases warm the planet, and more than 90% of that excess heat from global warming has been transferred to the ocean, as you can see in this figure, which shows ocean heat content over time, which sharply increases over the last few decades. Additionally, a fraction of the carbon dioxide we release to the atmosphere dissolves directly into the ocean, where it causes changes to seawater chemistry, like ocean acidification. This figure shows the signature of ocean acidification at a time series site near Hawaii, which manifests as decreasing ocean pH, or increasing acidity, as well as decreasing carbonate ion concentration. Ocean acidification is detrimental to various ocean species, including oysters and other shellfish, as well as corals and many different species of plankton. With my research, I've attempted to measure and explain changes in ocean chemistry and the cycling of elements like carbon that are influenced by both natural variability and human-induced changes to the environment. My research at UW has and will continue to focus on the chemistry of the California Current large marine ecosystem, which is a dynamic ocean system off the west coast of North America. The California Current system is what's known as an eastern boundary current upwelling system, which means that seasonal winds cause ocean currents that bring water from depth to the surface of the ocean, bringing with it vital nutrients that support phytoplankton growth. As you can see in this figure, which shows phytoplankton production in the California Current region, which is especially high near the coast. These phytoplankton form the base of a thriving biological community, supporting, among other things, numerous fisheries that are economically important for the United States. One of the tools I'm using for this work is the array of robotic profiling floats like this one that have been deployed in the California Current system. These figures show float deployments, first here in the mid-2010s, and then over the past year, and these floats will continue to make measurements into the future. These floats measure physical ocean properties like temperature and salinity, and also chemical properties like acidity or pH, oxygen concentration, and phytoplankton abundance. And they profile from depth in the ocean up to the surface every few days. This figure shows a time series of oxygen concentration over 3+ years for one of the floats that has been deployed in the California Current system. So this is exciting work that will help us to understand how the ocean off the west coast of North America absorbs and stores carbon, and how it responds to environmental changes like ocean acidification and ocean warming. So stay tuned. I hope to have some of my work published in the near future, and thanks very much for listening.